Good afternoon, students. So we will start with the class. Just 1 minute. I'll share the numericals for the today's class.
Good afternoon, ma'am.
Yes, you remember all the formulas, or should I write all the formulas once? ನಾನು ನಿಮ್ಗೆ ಲೀಸ್ಟ್ ಮಾಡಿ ಅಂತ ಹೇಳಿದ್ದೆ. You have prepared the formulas for the current electricity. Yes, everyone. Okay, then we will start with the first question. Yes. Okay, the first question, at room temperature, the room temperature is given as 27 degrees Celsius. The resistance of a heating element is 100 ohm. What is the temperature of the element if the resistance is found to be 117 ohm? Given that the temperature coefficient of the material, andre alpha value kottidare. So 2 resistance value is given and the alpha value is also given. So let's see how to do this. That is R is equal to R naught into bracket 1 plus alpha delta T. That formula we are using. Yes. So nan directly alpha is equal to barita idini. The formula is alpha is equal to, it is R2 minus R1. R ಮತ್ತೆ R0 ಬದಲಾಗಿ R2 R1 ಅಂತ ತಗೊಳ್ತಾ ಇದೀವಿ. So R2 minus R1 divided by R1 into bracket T2 minus T1. So here we require the value of T2. So therefore T2 minus T1 is equal to R2 minus R1. R2 ಅಂದ್ರೆ 117 ಇದೆ, minus R1 ಅಂದ್ರೆ 100 ಇದೆ, divided by R1 is again 100 inside the bracket. So ಇಲ್ಲಿ alpha ಬರುತ್ತೆ. Alpha is 1.7 into 10 raised to minus 4. So if you simplify this one we will get it as 1000. So T2 minus T1 is equal to, ಇದನ್ನ 1000 ಅಂತ ಬರುತ್ತೆ, ನೀವು ಬೇಕಾದ್ರೆ ಚೆಕ್ ಮಾಡಿ ನೋಡಿ. Therefore T2 is equal to, therefore T2 is equal to 1000 plus 27, that is nothing but 127 degrees Celsius. So answer we are writing in terms of degree Celsius. Yes, Sri, you are correct. Yes, copy down the answer and the question. We will go for the next question.
Yes, ma'am, over.
Yes, students, the next question. A silver wire has a resistance of 2.1 ohm at 27.5 degrees Celsius and a resistance of 2.7 ohm at 100 degrees Celsius. Determine the temperature coefficient of resistivity of silver. So determine the temperature coefficient of resistivity. That is nothing but alpha only. So therefore alpha is equal to the same formula, R2 minus R1 divided by R1 into bracket T2 minus T1, which is equal to 2.7 minus 2.1 divided by 2.1 into bracket 100 minus ಮತ್ತೊಂದು temperature 27.5 ಇದೆ. So substitute here 27.5. So therefore 2.7 minus 2.1 is 0.6 ಆಗತ್ತೆ, 0.6 divided by 2.1 into 100 minus 27.5 is 72.5. So further you can simplify. 72.5 into 2.1 ಮಾಡಿ ಕಡೆಗೆ 0.6 ಇಂದ ಅದನ್ನ ಡಿವೈಡ್ ಮಾಡಿ. Yes, Srivarni, correct. Very good. No alpha value, how you will get it? See, 2.1 into 72.5, then 0.6 ಇಂದ ಆನ್ಸರ್ ಅನ್ನ ಡಿವೈಡ್ ಮಾಡಿ ನೋಡಿ. 0.0039 ಬರುತ್ತೆ. Yes, check students. Yes, correct. That is 0.00, 152.25. Yes. So denominator 2.1 into 72.5 ಮಾಡಿದಾಗ 0.00394 ಅಂತ ಬರುತ್ತೆ. ಮತ್ತೆ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ ಇರೋದು 0.6. Sorry, this is 122. 152. Denominator 2.1 into 72.5 ಅಂತ ಅಂದ್ರೆ this is 152.2. Yes, yes. Sorry. Answer ಅದ್ ಬರುತ್ತೆ. Answer is 0.00394 per degree Celsius. Let's copy down everyone. Okay. The next question. A heating element using nichrome connected to a 230 volt supply. It is connected to a 230 volt supply, draws an initial current of 3.2 ampere, which settles after a few seconds to a steady value of 2.8 ampere. What is the steady temperature of the heating element if the room temperature is 27 degrees Celsius? Temperature coefficient of resistance of nichrome averaged over the temperature range involved is 1.7 into 10 raised to minus 4 degrees Celsius. So ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ no doubt alpha value ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ ಲಾಸ್ಟ್ ಅಲ್ಲಿ. Other than that, what all they have given, see. A heating element using nichrome connected to a 230 volt supply. ಹೌದಾ? So 230 volt supply ಗೆ draws an initial current. So initial current ಬೇಕಾದ್ರೆ ನೀವು ಇದನ್ನ I1 ಅಂತ consider ಮಾಡಬಹುದು. This you can make it as I1. And this is your V value, which settles after a few seconds to a steady value of. So ಇದು ನಿಮ್ದು I2 value ಕೊಟ್ಟಿದ್ದಾರೆ. This is your I2. I1 value, I2 value. What is the steady temperature of the heating element if the room temperature is 27 degrees Celsius? What is the steady temperature of the heating element if the room temperature is 27 degrees Celsius? ಮತ್ತೆ alpha value ಕೊಟ್ಟಿದ್ದಾರೆ. So T2 value find out ಮಾಡಬೇಕಾಗಿದೆ students. T1 value 27 degrees Celsius ಅಂತ ಇದೆ. T1 value is given. Okay. So ನೀವಿಲ್ಲಿ coefficient of resistance alpha ತಗೊಂಡು ನೀವು ಇದನ್ನ ಮಾಡಬಹುದು. That is R2 minus R1 divided by R1 into bracket T2 minus T1. So T1 ಇದೆ, T2 find out ಮಾಡಬೇಕಾಗಿದೆ. What about R1 R2? R1 R2 ಕೊಟ್ಟಿಲ್ಲ. R1 R2 is not there in the question. So when R1 and R2 is not there in the question, first ನೀವು ಅದನ್ನ calculate ಮಾಡಬೇಕಾಗತ್ತೆ according to Ohm's law. So first ಗೆ ಏನ್ ಮಾಡಿ R1 R2 values ಅನ್ನ find out ಮಾಡ್ಕೊಳ್ಳಿ. R1 is equal to according to Ohm's law V divided by I1 ಅಂತ ಆಗತ್ತೆ. This is 230 divided by 3.2, which is equal to 71.875 ohm. Then next R2 is equal to V divided by I2 is equal to 230 divided by 2.8, which is equal to 82.143 ohm. So this is R1 R2 value. T2 867. Yes, very good, correct. ಹಾಗಾದ್ರೆ T2 minus T1 is equal to R2 minus R1 divided by alpha into R1 ಅಂತ ಬರೀರಿ. Okay, R2 R1 value ಬಂದಿದೆ ನಮ್ಗೆ already 82.143 minus 71.875 divided by alpha is 1.7 into 10 raised to minus 4 into R1 71.87. So subtract, divide, ಬಂದಿರೋ ಆನ್ಸರಿಗೆ T1 ಅನ್ನ ಆಡ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ ಆಯ್ತಾ. ಚೆಕ್. Here you should get around 840. T2 minus T1 ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ. Do it students. ಓಕೆ. T2 minus T1 is 840 ಬರುತ್ತೆ ನೋಡಿ. 840.25 ಬರ್ಬೋದು ಐ ಥಿಂಕ್. 843. ಓಕೆ, ನಿಯರ್ ಬೈ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಫೈನ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ಸೊ ನೀವು ಎಷ್ಟು ಡೆಸಿಮಲ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ ಅದ್ರ ಮೇಲೆ ಇರುತ್ತೆ. ಸೊ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ಐ ಕನ್ಸಿಡರ್ ಇಟ್ ಆಸ್ 840 ಅಂತ ಬಂದ್ರು T2 will be 840 plus 27. So around 867. ಓಕೆ, ನಿಮ್ದು 867 ಬರ್ಬೋದು ಅಥವಾ ಪಾಯಿಂಟ್ಸ್ ಅಲ್ಲಿ ಮತ್ತೆ ವ್ಯಾಲ್ಯೂ ಬರ್ಬೋದು. ಅಬೌವ್ 865 ಎನಿ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಫೈನ್. 860 to 870 ರೇಂಜ್ ಅಲ್ಲಿ ಬರುತ್ತೆ ನೋಡಿ. ವೈ? ಬಿಕಾಸ್ ನೀವು ಎಷ್ಟು ಡೆಸಿಮಲ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅದ್ರ ಮೇಲೆ ಅಲ್ಲಿ ಡಿಪೆಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಕೆಲವೊಬ್ರು ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ ಡೈರೆಕ್ಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ. ದಟ್ ಟೈಮ್ ಇಟ್ ವಿಲ್ ಟೇಕ್ ಆಲ್ ದ ಡಿಜಿಟ್ಸ್. ಸೊ ಸಪರೇಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋರು ಇರ್ತಾರೆ. ಸೊ ಇಟ್ ವಿಲ್ ಚೇಂಜ್. 67, 68, 69 ಯಾವ ವ್ಯಾಲ್ಯೂ ಬಂದ್ರು ಫೈನ್, ನೋ ಪ್ರಾಬ್ಲಮ್. ಯೂನಿಟ್ ಬರೀರಿ ಆಯ್ತಾ. ಡೋಂಟ್ ಲೀವ್ ದ ಯೂನಿಟ್. ದ ಟೆಂಪರೇಚರ್ ದೇ ಆರ್ ಆಸ್ಕಿಂಗ್, ಸೊ ದ ಟೆಂಪರೇಚರ್ ಇಸ್ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್. T2 will be degree Celsius.
Hey, hey, hey.
Okay, hope so everybody copied the question as well as the answer. I'll go for the next question. The next question, the current flowing through the filament of an bulb is 2 ampere. So current ಎಷ್ಟಿದೆ? 2 ampere ಇದೆ. What quantity of charge flows through the filament in 30 minutes? How many electrons pass through the filament in the same time? So what all they are asking? The current flowing through the bulb is, it is 2 ampere ಅಂತ ಹೇಳಿದ್ದಾರೆ. What quantity of charge flows through the filament in the time interval of 30 minutes? How many electrons pass through in the same time ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. You have to calculate the number of charges. So first lesson ಅಲ್ಲಿ quantization of charge ಒಂದು ಫಾರ್ಮುಲಾ ಇತ್ತು ನೋಡಿ. You have to calculate n from that. ಆಯ್ತಾ? So quantization of charge is equal to Q is equal to n into E. Therefore n is equal to Q divided by E. But first Q ಎಷ್ಟು ಬರುತ್ತೆ ನೋಡಿ, because charge is not given there. ಹಾಗಾದ್ರೆ current equation ಅನ್ನು ನಾವಿಲ್ಲಿ ಯೂಸ್ ಮಾಡಬಹುದು. ಟೈಮ್ ಹಾಗಾದ್ರೆ charge is equal to ಏನಾಗುತ್ತೆ? It becomes I into T. What is I value? I value is 2 ampere. Then the time value is what? It is 30 minutes. So seconds al ತಗೊಳ್ಳಿ 30 into 60, which is equal to Q. Exam 3600 coulomb. This is the charge value. ಹಾಗಾದ್ರೆ n ಎಷ್ಟು ಬರುತ್ತೆ? Q by E is equal to n, and this is 3600 divided by 1.6 into 10 raised to minus 19. Just check out and tell me what is the value of n. Ten to the power plus barata minus barata. Numerator minus 19. If you take it to the denominator, it becomes plus 19. So 3600 divided by 1.6 is nothing but 2250 ಆಗುತ್ತೆ into 10 raised to plus 19. If you want, you can shift the decimal also. So ಇದನ್ನ shift ಮಾಡಿ ಕೂಡ ಬರೆದ್ರೂ problem ಇಲ್ಲ. Otherwise, you can keep it as it is. Yes. Okay. Copy down. We will go for the next question. Okay, I asked my other colleagues. I did not ask sir. Today I'll ask you. Is completed?
Yes, ma'am.
Okay, next question. You try it yourself. A charge of 20 microcoulomb. So charge value is given 20 microcoulomb. Micro andre 10 raised to minus 6. Okay. Flows across a section of a conductor in 4 seconds, 4 milliseconds. Calculate the current. Yes. You need to calculate the current. The charge value is given as 20 into 10 raised to minus 6 coulomb. ಮತ್ತೆ ಟೈಮ್ ಎಷ್ಟು ಹೇಳಿದರೆ 4 millisecond ಅಂತ ಆಗುತ್ತೆ. Yes, you calculate and tell me the answer.
ಆಡಿಯೋ ಬರವಲ್ದು.
Yes, correct. 5 milliampere is correct answer. 5 into 10 raised to minus 3. So if you want, you can see the solution here. Yes. Okay. So we will continue with the next questions. Just a minute. I'll share that. Okay, see students, next question. A metal cube of edge 2 centimeter is drawn into a uniform wire of length 2 meter. What is the resistivity of the wire? The resistivity of the material of the wire is given 0.5 micro ohm meter.
ನಾನು ಮ್ಯೂಟ್ ಐತಿಲ್ಲ ನೋಡು.
Resistivity is given. See. See, ಏನೇನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ ಅಲ್ಲಿ. A metal cube of edge 2 centimeter. So the edge is given as 2 centimeter. Length is given as 2 meter. Length is given 2 meter ide. Okay, no problem. No need to convert that. Then the resistance we need to calculate. Resistivity is given 0.5 into 10 raised to minus 6 ohm meter anta kottidare. Okay. So the next one, to calculate the resistance. To calculate the resistance here, it is having a cube of edge 2 centimeter anta helidare. So cube with edge estide, that is equal to 2 centimeter. So 2 centimeter ana meter al madidre idu 2 into 10 raised to minus 2 meter anta agatte. As we know, the relation between resistance and resistivity, R is equal to rho into L divided by A. Hauda? So which is equal to rho into L divided by area ide. ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ ಅಂತಂದ್ರೆ I'll multiply and divide by L. So if I multiply and divided by L cancel ಆದ್ರೆ ನಿಮ್ಗೆ equation 1 as it is ಬರುತ್ತೆ. So what is area into length? Area into length is nothing but volume. Hope so you know this, because volume is equal to length into breadth into height ಆಗುತ್ತೆ. Length into breadth ಅನ್ನ area ಅಂತ ತಗೊಂಡು ಇದು ಏನ್ h ಇದೆ, I'll take it as L. So therefore denominator term volume anta aitu students, and the numerator term is rho into L square. Rho into L square. So you have the value of rho, you have the remaining all the values, you can calculate this. So for the cube, rho into L square divided by this volume is nothing but what? Length into breadth into height. ಹಾಗಾದ್ರೆ ಅದ್ರ ಕ್ಯೂಬ್ ಆಗತ್ತೆ. ಸ್ಮಾಲ್ ಎಲ್ಲು ಲೆಂತ್ ಅಂತ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ, ಕ್ಯಾಪಿಟಲ್ ಎಲ್ಲು ಆ ಎಡ್ಜ್ ಏನ್ ಲೆಂತ್ ಇತ್ತು ಅದ್ರದ್ದು ಮೆನ್ಷನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಫಾರ್ ದ ಕ್ಯೂಬ್, ಆಯ್ತಾ? So therefore now I can substitute the values here. The resistance is equal to resistivity 0.5 into 10 raised to minus 6. ಮತ್ತೆ ಸ್ಮಾಲ್ ಎಲ್ ಎಷ್ಟಿದೆ? 2 meter ಇದೆ, ಅದ್ರದ್ದು ಸ್ಕ್ವೇರ್ ಆಗತ್ತೆ. Divided by capital L cube is nothing but 2 into 10 raised to minus 2 whole cube. So you can simplify, see. Yes, 0.25 is correct. Yes, correct answer. Yes, very good. Yes, everyone, 0.25. Write the unit. Resistance ide ohm baratte. So please write the unit also. The next question. Again, I am telling you only the formula. You are going to solve it. Because theory ಅಷ್ಟು ಚೆನ್ನಾಗಿ ಕವರ್ ಆಗಿದೆ, ನಿಮ್ಗೆ ಬರಬೇಕು ಎಲ್ಲ ಆನ್ಸರ್ಸ್. So see, a copper wire of cross sectional area. So copper wire area ಎಷ್ಟು ಹೇಳ್ತಾ ಇದ್ದಾರೆ, 1 into 10 raised to -6 ಇದೆ. That is 1 into 10 raised to -6 meter square. ಮತ್ತೆ ಕರೆಂಟ್ ಎಷ್ಟು ಹೇಳಿದ್ದಾರೆ, it is 5 ampere. Find the current density. So ನಿಮ್ಗೆ already current density ಅಂದ್ರೆ ಗೊತ್ತಿದೆ. What is current density? J is equal to I by A ಅಂತ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಸ್ಟೂಡೆಂಟ್ಸ್. ಮತ್ತೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. For the free electron density of copper is given, that is 8 into 10 raised to -28 and ಅದು n ವ್ಯಾಲ್ಯೂ ಆಗುತ್ತೆ. n is equal to 8 into 10 raised to 28 electrons per meter cube. So already you know that to calculate the current density is equal to current per unit area ಮಾಡಿ, current ಕೊಟ್ಟಿದ್ದಾರೆ, area ಕೊಟ್ಟಿದ್ದಾರೆ, directly ಮಾಡಬಹುದು. ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಅವರು ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಕೇಳ್ತಾ ಇದ್ದಾರೆ. ಸೊ ನೀವು ಆಲ್ರೆಡಿ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಫಾರ್ಮುಲಾ ಡಿರೈವ್ ಮಾಡಿದೀರಾ ಸ್ಟೂಡೆಂಟ್ಸ್. ಇಟ್ ಇಸ್ I divided by NA into E. ಕರೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ನಂಬರ್ ಆಫ್ ಡೆನ್ಸಿಟಿ n 8 into 10 raised to 28, that is also given. Area 10 raised to -6 and charge of the electron 1.6 into 10 raised to -19 coulomb. So please substitute all the values, calculate current density and drift velocity and tell me the answer. So current density ಅಂತೂ 5 ಬರುತ್ತೆ, ಬಟ್ ಪವರ್ ಏನ್ ಬರುತ್ತೆ 5 into 10 raised to +6 ಅಂತ ಬರುತ್ತೆ. Yes, otherwise keep it as it is, 5 into 10 raised to 6 ಅಂತ ಬರೀರಿ. I is 5 divided by 10 raised to -6. So -6 ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ 5 into 10 raised to +6. So current density ampere per meter square. ಹಾಗಾದ್ರೆ drift velocity. The drift velocity is 5 divided by 8 into 10 raised to 28 into area into charge of the electron. Yes, Suraya, which one you are telling? Drift velocity or it is this one, current density? Current density 5 into 10 raised to 6. 5 into 10 raised to 6 and 5 after 5 you will get 6 zeros. Check with the drift velocity. Is any doubt in the question? Charge of the electron, small e andre charge of the electron, 1.6 into 10 raised to -19. Charge of the electron. Constant values you should not forget. Charge of the electron is 1.6 into 10 raised to minus 19. Mass of the electron is 9.1 into 10 raised to minus 31 kg. You should remember all the constant values. Constant values only list out ಮಾಡಿ. Like already you have studied 1 upon 4 epsilon naught kuda madidira, then epsilon naught gottide. So you know some constant values already from the 3 chapters. Please make a list of that. Repeatedly formulas constant values and revise ಮಾಡ್ತಾ ಇದ್ರೆ it will be easy for you for the competitive also. Competitive exams kuda help ಆಗುತ್ತೆ. Drift velocity 3.9 into 3.9 into 10 raised to minus 4. Drift velocity is 3.9 into 10 raised to minus 4. 5 divided by 8 into 1.6. So what you have 8 into 1.6 ಮತ್ತೆ power ಏನಿದೆ ನೋಡಿ 10 raised to plus 22 ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ minus 22 ಆಗುತ್ತೆ, minus 6 plus 6 ಆಗುತ್ತೆ, minus 19 plus 19 ಆಗುತ್ತೆ. So therefore 10 to the power 19 plus 6 is 25. 25 minus 28 is minus 3. ನೀವು just ಇದನ್ನ divide ಮಾಡಿ ಬಿಟ್ರೆ ಆಯ್ತು. Yes, check students. What is the answer? One more last question we will see. Current is 5 ampere. So your final answer is 3.9 into 10 raised to minus 4. If I make it 10 raised to minus 4, it is 3.9 into 10 raised to minus 4. This is drift velocity C. ನೀವೆಲ್ಲ ಮಿಸ್ಟೇಕ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, please check ಮಾಡಿ students. We have drift velocity is equal to I divided by NAE. I is equal to, it is 5 ampere, N is 8 into 10 raised to 28. A is 10 raised to minus 6. Charge of the electron 1.6 into 10 raised to minus 19. Yes, 3.9 into 10 raised to minus 4. Okay. So the last question for the today's class. The storage battery of a car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, what is the maximum current? What is the maximum current that can be drawn from the battery? Yes. So see, the solution is the EMF of the battery is 12 volt. Resistance, internal resistance ಕೊಟ್ಟಿದ್ದಾರೆ. ನಾನು ನಿಮಗೆ ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೆ internal resistance ಅನ್ನ small ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾರೆ, small r. Okay, according to Ohm's law we can write it as E is equal to I into R. So therefore I is equal to E is 12 divided by 0.4. So therefore it is 30 ampere. The current is 30 ampere. Yes, anybody got the answer? It is 30 ampere. Okay, so copy down.
ಮ್ಯಾಮ್,
Yes,
ಇದು I is equal to 30 AB ಏನು ಬರ್ಬೋದಾ?
I is 30 ampere. A is unit. Sorry, ampere we are writing it as capital A. Unit of the electric current. Is everyone completed? So tomorrow we will continue with few more questions on the wheatstone bridge and all we will do, aita? Okay, so revise the formulas. Tomorrow we will continue. Thank you.
Thank you so much, ma'am.